right. I am live with the second 52 weeks of AWS episode this week. And we talked about the AWS cookbook yesterday, which was pretty cool. I learned a lot about some of the infrastructure as code and really advanced AWS techniques from both of the cookbook authors. So that was pretty cool. Today, I'm going to dive into the solutions architect certification and just get through that material for the next several weeks. Maybe after that, we'll build microservices and do a little bit of coding, but it feels like a good time to break into some solutions architect material. I think many people are interested in getting that solutions architect certification. And let's go ahead and get started. So I'm going to go through here and share my screen here to start off with. And let's go to the solutions architect material. So to start off with, I have a bootcamp repo here, AWS Bootcamp, where you can go ahead and take a look at different slides. This is the one I'm going to start with, which is AWS Certified Solutions Architect exam. Let's actually just look at the exam overview first so you get a feel for it. And there's an exam guide, which I think is a great place to start. If you're going to pass an exam or going to try to pass an exam on AWS, this is the first place to start, is look at the target candidate description, see the things that you're required to do, look at the overview of the exam content. So in this particular scenario, we see that this particular exam has both multiple choice and multiple response. Now, the problem with multiple response is that it can have two or more correct answers, right? So it's going to be a very complex question. And so you really do need to know the material when you see a multiple response. And then afterwards, it says the minimum score is 720. Roughly, I think that would be like something like 72% of the content would be you'd have to be successful on. And then in terms of the domains, we've got domain 1, which is design resilient architectures. That's 30% of the exam. We've got domain 2, design high performance architectures. That's 28. Domain 3, design secure applications and architectures, 24%. And then domain 4, design cost optimized architectures, 18%. So if we look through here, this is a great way to determine a study plan for yourself. Look through the hierarchy of the domain. So design a multi-tier architecture, design a solution based on, access patterns, design, highly available and or fault tolerant architecture, design decoupling mechanisms using AWS services, choose appropriate resilient storage. So that's domain 1. 2 is high performance architecture, identify elastic and scalable compute solutions, select high performance and scalable storage solutions for a workload, select high performance networking solutions for a workload, and choose high performance database solutions for a workload. Domain 3 is design secure applications and architecture. So securing access to AWS resources, designing secure application tiers, selecting appropriate data security options. Domain 4 is cost optimization architecture. So cost-effective storage. This is where you run into things like Glacier, for example, for backups, or policies for S3. Identify cost-effective compute and database services, and then design cost-optimized network architecture. So that's the domain, the exam guide. And one thing I always tell people is that make sure you understand the terminology. That's one of the easiest ways to get tripped up. And they give you the terminology at the very end. And then the other thing that's easy to get tripped up on is that they'll tell you what white papers to study. If we go down here, they'll tell you AWS white papers, right? So make sure that you study the white papers that they recommend for that particular exam. So that's really the background here for getting started with it. I'm going to go to the slides, which I have a link to right here, Solutions Architect slides. And I'm going to start off right at the beginning here, and we'll go right into module 1, maybe get a couple modules out of the way. So here's the material here that we'll start off with, which is AWS Academy Cloud Architecting. And what is the overview is to make sure that you understand how to pass the exam, right? That's the first one. Also that you have had some background potentially in the solutions architect, pre-material, so cloud practitioner, and you have general IT knowledge. Those are some of the prerequisites. After you're done, you should be able to make architectural decisions around services, also be able to do the correct performance, efficiency, reduce costs, make sure you do the well-architected framework. And then this is just an overview of the different things that we'll go over the next several weeks. The module, this one, cloud architecting, storage, compute, database, network, securing user and application access, elasticity, automated architecture, caching content, building decoupled architecture, building microservice and serverless architecture, plan for disaster, and then bridging to certification. So basically, that's the overview. And so I can just move on down to the first real module that has material. And I'm going to dive right into this. And introducing the cloud architecting is what we're going to cover. And so if you go into this introducing cloud architecture material, a few things to be aware of to start with is this would be an idea of a large architecture. You would have, the user would go to Route 53. It would actually have some assets in CloudFront, the CDN. The user would also, be able to pull data that originated from S3 that migrated to CloudFront. There's an internet gateway, there's a VPC, there's a public subnet, a private subnet, there's EC2 instances, there's maybe a Amazon relational database or RDS around. Maybe there's EFS, right? The Elastic File System, Mount Point. These are all the things that could be involved in a large scale architecture. And in my experience in working with AWS, in building, huge companies on AWS, this is very similar. In fact, many of these things were things that I did when I built out an architecture. So what is cloud architecting? A good example would be around 2000, Amazon was struggling to make its new shopping website highly available and scalable. And so, Amazon e-commerce was a jumbled mess, and they had difficulty separating the different services because everything was monolithic. And so this is also kind of a thing whenever I hear people talk about monolithic web frameworks, and these used to be a big deal. It's not actually a good pattern, in my opinion. The microservice pattern is a much better pattern. And so Amazon went through this API-based approach. And so even though there were still problems, database, compute, and storage components took 3 months to build. And so they built internal resources at Amazon so that you're able to build things on top of this infrastructure. So in a nutshell, a cloud architecture involves, business goals, the structural design, and then you build out the complete structure. So let's look at the well-architected framework here. This is a foundational skill to acquire if you're going to pass the certification for solutions architect. The pillars are the security, operational excellence, reliability, performance and efficiency, and cost optimization, right? Those are the pillars of a well-architected system. And in terms of security pillar, you would have the identity foundation, traceability, security at all layers, and risk assessment and mitigation strategies. Operational excellence pillar, this would mean that you can run your systems and monitor them. So you would be able to continuously improve the deployment process, the update process, the operations process. In terms of reliability, you're able to recover quickly from infra or service disruptions, basically dynamically acquire resources to meet demand, and also handle disruptions like you accidentally misconfigured a YAML file, or you have some kind of network outage that's transient. This is the ability to handle that. And if you design your system correctly, it won't matter if those issues occurred. In terms of performance pillar, this would mean choosing the right things for the job. So are you efficiently choosing resources and maintaining their efficiency? Are you democratizing advanced technologies? So if, let's say, containers or microservice technologies like AWS App Runner come out, are you able to provide those to your developers? And are you able to employ mechanical sympathy? So this is basically when you use a tool that understands how it will operate best. And so you're using a technology approach that aligns best to what you're trying to achieve. For example, database, if it's a key value database versus a relational database. Cost optimization pillar, this would be measuring efficiency, eliminating unneeded expenses, consider using managed services. This is a really a classic anti-pattern that I've seen in the Bay Area is organizations start using AWS and they don't do it efficiently because they're not following the principles of a well-architected framework. And so cost optimization is one of those. And in AWS, they have this well-architected tool, and this helps you review the state of your workload and compare them to the latest in AWS best practices, gives you access to knowledge and best practices by AWS architects, and also helps you deliver an action plan with step-by-step guidance on how to build better workloads for the cloud. All right, so in a nutshell, the well-architected framework is a foundational component of learning AWS, and it really is a good practice. So let's go into the best practices for building solutions on AWS. There is a design trade-off. And the idea here is that you evaluate a trade-off so you can select an optimal approach. You have trade-offs that include consistency, durability, space, latency. You prioritize speed to market. You base design decisions on empirical data. Now, in terms of scalability, one of the things that you have to be aware of is that your architecture can handle changes in demand. So users cannot access applications, because let's say the server is full. Well, what would you do? Well, an anti-pattern would you have a bunch of humans that would go and click a button and launch a new server. I cannot tell you how many organizations I've worked at, especially in the Bay Area, believe it or not, where they have an operations person that must be, sitting through and scaling things. I've gotten in big disagreements over the years about, the fact that organizations have done this. Finally, the world is now at a place now where people realize that this should be automated. Now, in terms of scalability, the ideal scenario would be you'd use something like Amazon EC2 auto scaling and it automatically scales out. Also, with automating your environment, if something crashes, you don't have the admin person come in, click a bunch of buttons, and then you deploy a server. It should automatically scale up, and that's one of the best practices. And in terms of resources as disposable, so you don't want to basically keep like hard-coded IP addresses and keep the same server around. It's better to be constantly terminating these resources and switching things. So you're exercising the dynamic nature of cloud computing. And in a way, it's almost like the human body, the cells are, constantly like, regenerating. The same thing goes with the cloud. You should be constantly regenerating your environment. So using a loosely coupled environment as well, I think is a great idea. So you design your architect with independent components. An anti-pattern would be a web application, which would also have an application server. So, and this is, I think, something that is pretty interesting because even today in Python, a lot of people talk about, monolithic web frameworks, and there's job titles that have monolithic web frameworks in them. But in fact, AWS is specifically telling you it's an anti-pattern to have a web server that is, directly an application server, and you have it all tightly coupled together. Really, with the cloud, it's a new way of thinking. And these monolithic web frameworks, even if they're built for perfectionists on a deadline or whatever, marketing buzzword they're telling you, is not actually a modern way to develop applications. Microservices are a modern way to develop applications. And the best practices are you have things that are microservices, they're load balancing, and they're decoupled in your solution. You want to design a service as well, not a server. So an anti-pattern would be simple applications that run on persistent servers. A best practice, though, would be message queues, for example, that handle the distribution of a load or a static website, using S3. Also, choosing the right database. Again, what I've seen a lot with a lot of these monolithic web frameworks will make you choose a relational database, and it's actually just ridiculous because In fact, many solutions require different kinds of databases for different problems. And so if it's more designed to be a microservice-based web framework like Flask or a Fast API, for example, in Python, then you're able to actually be flexible. And so this is a best practice is with AWS, don't always immediately go to a relational database just because your web framework, for example, told you and your friends are angry at you if you if you use some other solution. You need to choose the right database for the problem at hand, and avoid single points of failure as well. You don't want to have everything in one monolithic application. A best practice would be you have application servers, you have database servers, you have a secondary database server, your main database, if it goes offline, there's replication. Really, the single points of failure is a real problem that should be avoided. And then also optimizing for cost here, basically taking advantage of the flexibility of AWS. Are you actually choosing the right resources and maybe even going event-based as well, right? Like, again, one of my problems with monolithic web frameworks is they're just churning up all this energy, burning up the rainforest in South America to do nothing, where with event-driven architectures, you can wait until you actually need to do something and then you process that event. So I think optimizing for cost could be dumping your monolithic web framework. Also using caching. So caching minimizes redundant data retrieval operations, improves performance and cost. So again, an anti-pattern would be, basically requesting, a bunch of stuff on S3 where maybe you want to cache certain things on CloudFront because the caching could be really a really good latency for the user. And especially you see this with static-based websites. You also want to secure your entire infrastructure. And so this is really an integrated kind of security versus having, basically a castle where once you get into the castle, everything is basically broken into. You want to have isolated parts of your infrastructure, encrypt your data in transit and rest, also enforce the PLP or principle of least privilege, use multi-factor authentication, use managed services, log access, automate the deployment, right? All of these things have to be built into each of the layers that you deploy into AWS. All right, so global infrastructure is another big one that comes up. And so the terminology, I think, is what trips people up with infrastructure, and in particular, region is a good one to get into. A region is just a geographic region. So it could be London, Ireland, Paris, Frankfurt, right? And your region consists of at least 2 AZs or availability zones, and you can communicate between the regions using the backbone network infrastructure. And you can also do data replication between regions. An availability zone is something that is one or more data centers. So it's at least one, but most likely more than one data center. And they're designed for fault tolerance, and they're interconnected with very high-speed networking. And so a good example of why you would want to use multiple availability zones in a particular region would be a relational database. You would replicate the relational database across multiple availability zones so that if there's an outage, you can transparently shift over to that, basically the backup copy of the database. AWS local zones, this enables you to run latency sensitive portions of the application close to the users. And this is a good way to handle things in terms of an AWS region. AWS data centers, this is where the data actually physically resides. And a typical data center has, let's say 20,000 to 50,000 servers. Here they're telling me tens of thousands of servers, but all data centers are online and serving customers. And the AWS custom network equipment as well is designed for AWS. Here's a good diagram of what's going on in a global infrastructure. Here we have points of presence. The edge locations are the blue. So these would be locations where your data would get cached. The multiple edge locations means it's probably like a really busy location. And so they have multiple edge. And then a regional edge cache would be areas where there's a particular region that you would cache things out to. The AWS global infrastructure consists of regions, availability zones, and edge locations. The choice of a region is basically either compliance or latency. Those are the two main reasons. Like in Europe, they have different data regulations. Each availability zone or AZ is separate, and so they have redundant power, networking, connectivity. Edge locations and regional edges caches improve performance by caching content to users. Well, that's I think our module for module 2. And I think I have time to cover module 3 as well, which would be let's see here. I'm going to go to Google Slides and see if this thing will still open. I might have to, this thing is so big, I might have to download it and then open it back up again. Let's see. Okay, I'm going to share my screen again. And let's see if I can get this thing cooking here. Okay, so I am going to just share this out. Slides, your computer. I'm going to go ahead and get a slide I just downloaded and put this into, that doesn't work. I'm going to share my regular screen then. Window, here we go. All right, so I got PowerPoint up here, and I'm on storage layer, and I'm just going to keep this view. I think this is a decent view to keep here, and adding storage layer. So let's get into this. Basically, the storage is a part of a larger architecture, and in the case of a static website, right, it could be S3. And a good example that they're starting with is this cafe. They want to do a static website. How would you architect this system? And that would be a good one to kind of think through. Now, an object storage service, or S3 here, it is where you would store unlimited amounts of unstructured data. And in particular, 5 terabytes is the maximum file size for a single object. And you have REST access, and all objects have key, version ID, value, metadata, and sub-resource. Now, the S3 benefits are it has 11 nines of durability. It has scalability, so you basically don't have to worry about scaling up and down. You get that automatically. There's also availability, and so the regular storage class is designed for 4 nines of availability. It has fine-grained security and performance. So what are some of the common usage patterns here for S3? Well, in a nutshell, I think one of the usage patterns you see is web content and media. I personally use this. I generate static websites and put them out. So that's a great way to use S3. One of the things you can do is you can actually secure them by doing things with the principle of least privilege. And so newly created S3 buckets and objects are private and protected by default. So you have to actually open those tools up. The 3 general approaches are going to be: default is basically no one gets it but the owner. The second general approach would be public. So you would go through and, I don't know, share some movie files out or something like that. Another one would be an access policy by S3 security settings. You can also encrypt everything in S3. That's a good thing to be aware of. Is with S3, you can go through and build out, for example, server-side encryption, client-side encryption. Another thing you can do is you can, as I mentioned, host static websites, and you can put HTML, images, videos, client-side scripts. I personally do it. It works very well. A best practice for S3 is versioning. And this is actually a really good point to bring up, is that when you version things, you also protect against accidental human error. It's really common to actually have a versioning problem with S3 where you accidentally deleted a file, but if it's versioned, you can always go back and roll it back, or you accidentally overwrote a file. So another thing you can do with S3 is it also has the ability to support cores or cross-origin resource sharing. so you can actually access it from a different domain with, let's say, JavaScript. S3, I have some videos on O'Reilly you can take a look at to look at static websites. But basically, another use case for S3 is data storage for computation and analytics. So you could take some data, drop it into S3, spin up, let's say, an EMR cluster, use Spark, go through, process some data, and then put the results back into, let's say, Amazon QuickSight. That would be a common big data type workflow. Another one would be backing up and archiving critical data. So you could actually take your physical data center and you could just copy maybe snapshots of those machines and put those into Amazon S3. The S3 data consistency model is read after write for puts of new object. Amazon S3 also gives you the ability to have eventual consistency for puts and deletes. So in general, S3 is a great general purpose object storage system with unlimited capacity. There are several different kinds of classes, and Amazon has S3 standard, which is frequently accessed data. That's the most expensive. There's S3 standard IA, so long-lived but infrequently accessed data. There's also S3 one zone IA, long-lived, infrequently accessed non-critical data. Amazon S3 Glacier or Deep Archive, archiving rarely accessed data. Amazon S3 lifecycle would be, you would have maybe 30 days Amazon S3 standard, then you would go to standard IA after 60 days, and then maybe after 365 days, you go to Glacier, something like that. And then finally you would delete it. That kind of lifecycle policy would be a great way to optimize cost. So the cost is you only pay for what you use. So essentially the gigabytes of objects per month, also the transfer out to other regions. You don't get charged though for transfer in or transfer between S3 buckets. And also you don't get charged for transfer out to CloudFront or delete and cancel requests. Okay, what about moving objects to S3? How do you do that? One way to do it is by using the browser. That's something I do all the time. A second way would be to use the AWS S3 command. I do this quite a bit myself, as I'll bring up AWS Cloud Shell, do AWS S3 CP or sync. I use the sync command a lot as well. The tools and SDK, there is actually Cloud9 has the ability to do things with S3, and also Python Boto 3 or C#, .NET, SDK, whatever SDK you're using, you can also use it to communicate with S3. Multi-part upload. So you can actually upload multi-part upload by basically having a file that's broken into different parts. Typically, though, you only would want to do this for 100 megabyte or above files, but you can quickly recover if there's a network issue. So if you were going to copy, let's say, a 5 terabyte file, using a multi-part upload would be the way to go. Amazon S3 transfer acceleration. So this optimizes network protocols and the edge infrastructure. This can be 50 to 500% cross-country transfer of large objects. And in some cases, it can even go faster. So that's a good thing to be aware of if you're transferring a lot of big data files. Another thing you can do, which is not really known to many people, is that you can do AWS Snowball. I used this at a company that I worked at, where you have petabyte scale data transport. So essentially, you go through and you take, let's say, 10 petabyte structure, and you put it onto the storage system, and then you go through and you ship it over to AWS. It would just, it could take, in this example that they're quoting, they say to transfer 10 petabytes over the internet, even if you have a 10 gigabit upload, it would take you 100 days. Where if you just physically go and ship it into the drive, the Snowball drive, and then mail it to AWS, you're going to get it there much, much faster. So there is actually a use case for Snowball. There's also Snowmobile, believe it or not. This is exabyte scale data transport. So basically a shipping container, a 45-foot long shipping container comes up, and it's attached to a semi-trailer and with a truck on it. and you can transfer 100 petabytes per snowmobile, and then it offers multiple layers of security. So basically, you just have people come up and ship a whole truckload of data to AWS. So it's pretty cool. So what about choosing regions for your architecture, data residency, and data regulation? So European Union, for example, has much different data regulation. Also availability and cost. Not all AWS services are available to all regions. So this happens a lot. You'll see a service that will only become available in, let's say, the US East, Virginia region. So you have to decide, which region to use. Also, the cost can be different for different regions. So it's important to be aware of those costs. And so maybe the last thing that we'll talk about here would be just that in terms of the module wrap up is that you should know about S3, how to store things inside of S3, and also the different storage classes and cost considerations, and how to choose a region and create a static website. So really, in a nutshell, we were able to cover a couple of things here on AWS for the Solutions Architect exam. And each week I'll just cover a little bit more. In a nutshell, go ahead and follow along, and hope to see you again next Tuesday at 4 p.m. Eastern Time. All right, talk to you later.